Yes, good morning. I'm very much glad to give a talk on blockchain and its applications. In this session, I'll just touch the surface of the importance of blockchain and what exactly the meaning of blockchain and how exactly the blockchain works. Blockchain is a kind of network. If you would have heard of this name, like centralized network, decentralized network, peer-to-peer network. Blockchain is a kind of decentralized network. We don't have any kind of intermediate person to control over the network. Okay, that is the meaning of blockchain. Where I'll just give the basic introduction towards blockchain, then I'll go with the functionalities of the blockchain, and if time permits. I'll give some different examples and applications of blockchain, and at last we can go with the question and answer. If you have any questions, you can post your question. I can answer for that. Blockchain mainly talks on wherever the centralized network takes over the control of all the nodes in the network. That can be removed. That is, single point of connection can be removed with the help of blockchain technology. We don't have any kind of single point of connection. Each and every node will behave like an individual host or individual device. Okay, that is the main importance of blockchain, and it was mainly developed by the generic example, generic definition. What exactly the meaning of blockchain is: a continuously growing list of records. We will call that individual node or individual host here it as blocks. Okay, and such blocks are connected to each and everyone, and hence it is called as a chain of blocks, and hence it is called as blockchain technology. Okay, this phenomenally growing across the globe, and it took its shape like anything, and it provides higher security compared to the existing computer networks using some cryptographic algorithms and all. Mainly, it was developed by two very famous scientists. One is Haber and Scott. They are very famous scientists who introduced the blockchain. There's lot of difference between Bitcoin and blockchain. People will have a misinterpretation between Bitcoin and blockchain. Bitcoin is a false currency. Sometimes we can also call it as a pseudo currency that is nowhere related to the blockchain. Blockchain is a mechanism or technology. Bitcoin is a currency. I mean to say, it's a false currency or duplicate currency that is totally different from blockchain. Okay, in the blockchain mechanism, we can make use of bitcoins for the respective operations and all. Okay, so this is what exactly the meaning of blockchain and the basic introduction towards it. And what it consists of mainly, blockchain mainly consists of three important patch of information. One is called as data, followed by previous hash value, followed by the hash value. Okay, data which you are intended to communicate to the other people or other network in the other nodes in the network, will call such information as a data. Hash value, okay, I'll focus much on hash value in the upcoming slides. Hashing is a technology in cryptography where exactly we will get the hash code at the output as a hash code. We will give input as a data, whatever the data it might be, any data. It might be numbers, it might be space, whatever, anything which you are going to pass, audio file, video file, text, image, whatever you are going to pass as an input for the hashing algorithm. It will give a code. That code is called as hashing code, or commonly called as hash code. And we have a lot of algorithms to convert the data to hash code. Out of such algorithms, we are going to use one specific algorithm for blockchain. I'll speak much on that also in the upcoming slides, and that is your previous hash value. And the previous hash value is nothing but the previous block hash value, and the hash value generated for this particular data, in this example hello world, and that hash value is the current hash value. Okay, there will be a question like what about the first block? Okay, any block will have three piece of information. One is data, one is previous hash, and one is hash value. What about the first block? Okay, and that block will never be having any kind of previous hash value, and such block is called as genesis block. Okay, the first block of a network, we can call it as a genesis block, and that block will be not having any kind of previous hash value. Okay, so the first block going to generate apply the algorithm of hashing algorithm, and it's going to generate a hash value, and that hash value will be the previous hash value for the second block. Okay, I hope so you got the basic information on blockchain. And they had depicted the fingerprint, because each and every block will be having individual unique piece of information which consists of three entities. So what I had depicted. Okay, you keep this in your mind so that you can able to relate to the other things around say. And the first block, as I said, it is called as genesis block, and the second block we can call the first block hash value as the second previous hash value, and the current hash value will be the hash value generated for the respective data of that particular block. Okay, so all the blocks are chained together. Why they had given the chain in between? Because each and every block are connected. If one block fails to work, the automatically the preceding blocks fails to work. Why? Because they all completely depend upon the previous hash values, right? So that is a main fantastic security mechanism what they can inculcate in this blockchain. Okay, and mainly this blockchain possesses five important principles. One is called as commonly known as consensus protocol, hash cryptography, and immutable ledger, and distributed peer-to-peer network and mining. We'll see one by one in the greater details of it, so that you can able to understand how exactly blockchain works. And I'll give in the meanwhile I can give pretty good examples so that you can able to understand how they work and all. Consensus protocol, sorry, hashing. I'll go with the hash cryptography first. Cryptography might have been heard of few people. Cryptography is a network security method where the actual data will be never sent as it is. They'll send in the form of cipher. I mean to say coded data. And why? Because the unauthenticated user, if he able to involve in the network, he should not able to read the data as it is. So the data will be in the form of coded data. Okay, so in that category of cryptography, there is one of the finest hashing algorithm we are going to use in this particular blockchain technology, and I'm going to deal with that first. The very phenomenal hashing algorithm what we have is SHA-256, called a secure hash authentication algorithm, and the 256 is a number, or for your convenience I can call it as a version. Like we have SHA 64 and so on. We have other algorithms like HMSE, hash message authentication code. That's also one of the hashing algorithm. Out of all those hashing algorithm, this algorithm possesses strongest security out of all those things. So they had inculcated this hashing algorithm for the blockchain technology. Okay, I think you can refer to this picture where they depicted such a way that each and every individual will be having unique fingerprints, right? There will be very rare case they have some small similarity between the fingerprints. In a similar way, biometric operation in the similar way, here also the hashing data, hashing algorithm or hash value, what they're going to get from each and individual block, that will be unique from the other blocks. Okay, totally unique. Okay, it will be not at all same as the existing block. It will be totally unique from the other block. That is a major thing what we can have here. The major difference between major advantage of having this cryptographic algorithm, SHA-256. Okay, the SHA-256 takes the input of variable and size, but it will generate the output of 64-bit alphanumeric pseudocode. Okay, please remember this. It will generate always 64 bits characters. That is the main fantastic importance of this blockchain. Hashing algorithm. It's not at all so easy to you can't able to attack such hashing value and all. That's the main difference between that's the main advantage, or main prioritized advantage of hashing algorithm. Okay, the data input data might be of anything. It might be text data, audio data, video data. So what we had depicted here, the input data might be of anything, but the output will be of always 64 characters alphanumeric data. Okay, that is the major thing. And this hashing algorithm possesses five important features or characteristics. One is one-way hash function, one-way mechanism or one-way function. Hashing algorithm is a one-way function. What is the meaning of one-way function? If I know the data value, I can able to generate the 64-bit alphanumeric value. But wherein case, if I know the 64-bit ASCII, alphanumeric value, I could not able to generate back here actual data. I mean, whatever the data we have. Okay, so even though we made 64-bit alphanumeric value as a public data or a public value, the user cannot able to depict back the actual data. That is the main fantastic feature of hashing algorithm, SH1, and that is hence it is called as one-way function. And deterministic. Okay, the values what the output what we get from the hashing algorithm, those value will be not similar or not same or not redundant. Okay, it will be completely unique, hence it is called as deterministic value or deterministic hashing value will get. Okay, and the computation, the time what it used to spend on that particular data, it will be of not so small. It will take huge amount of I mean, it will not take it might be a huge amount of data also. It will take very less amount of time, very less amount of time to generate the 64-bit hashing value. Hence it is, they call it as fast computation. And we have one more important feature, we can call it as avalanche effect. Avalanche effect, I think the word actually the avalanche effect is a very famous attack or mechanism what we have in cryptography. The It states that a small change, a very small change in a data or the hash value, that will affect the output very drastically. It might be of a small, if it is 1 to 0 or 0 to 1, it might be, but the output it will change a lot. Okay, that is the meaning of avalanche effect. That will adhere this SH algorithm, 256 algorithm will adhere to that also. And the last important feature is called as it has to withstand collision. Okay, you may have a question like. At the same time, at the small at the peak time or same time, few people may also have the hashing algorithm for same data. Okay, same time. Okay, there will be a collision, right? Two people or two blocks will able to determine the hash value using the same algorithm at the same time. Or it might be like if the value, or if the user they want to get the output at the same time. Okay, so what they'll do, they will consider the time slices or timestamp. Okay, now they used to bother about at which time or at what time the user the user has committed to generate the hashing code. That individual time slice they'll consider, and based on the individual time slots, they'll give the different hashing values. Okay, that is a major difference. If it is of the same time, the time slots, the time slices also will be considered. Okay, that is the meaning of withstand collision. It will not collide each other by generating the same kind of hashing value and all. These are the 5 important features or characteristics what hashing algorithm possesses. Okay, one is one way, one is deterministic, one is fast computation, and one is avalanche effect, and it will also withstand collision. I'll speak something like this. I think you might. I'll show you something like uh, this. I think you might also can able to see this. I guess called super data sense. We have this. If you want, I can share that link also, or if anybody wants. Okay, this is what exactly a small can able to depict the blockchain with the help of this example. What we have, the block number 1, and nonce we have 7 to some number. Nonce is nothing but only once generated unique number, and that is called as nonce. And data, whatever the data you want to pass, let me consider data as high. Okay, if I for the whatever the data I'll embed, for that the hash value will be completely changed. You can see the change in the hash value. If I type hi, it will completely change. Okay, if I give the data value keep on changing, the hash value completely changes. Okay, what I want to tell you at the end of the day is the output what we generate out of this hashing value, it will be completely unique or completely different. Okay, it will be never the same. That is an important aspect what we have in the blockchain. Okay, and let me go for blockchain. And second important aspect which I want to depict for you people, let me consider the data, first data as something like VVCE. It will generate some hash value. I think if I give the mine, I'll talk on what is the meaning of mining and which mining algorithm, I mean how mining does in a greater details in the upcoming slides. For this complete, you can check out the first block what we have the nonce value, we have a data value. The previous hash value, as I said very clearly, that it will be not having any previous hash value. The reason is that it's not going to have any other previous hash blocks. Hence, it is called as the first block of your chain, and this hash value will be completely zero. And the hash value which will be generated for this data, it will be a current hash value, and this block is called as Genesis block. Okay, the second block you can check here. I'll change the data for the second block. Let me change the data for the second block. I'll give the data as something like CSE. Okay, let me give the hash value, data value of CSE. Okay, if that is the case, immediately if I go for mining that particular thing, immediately it will mine. I'll talk what is the meaning of mining and all later. Immediately it will mine, and immediately that will be converted to the other color. I mean to say the green color. Okay. Uh, Okay, that is the meaning of block. Once it converts to green color, it's mined properly, and it will show that the block is created. Okay, so eventually, once it is created, eventually the succeeding blocks will be also created automatically. That is the meaning of it's mined properly, right? Okay, so let me go for third block. Let me consider three blocks as an example for this particular operation. For that particular example, I'll take the data something like blockchain block, an example of data as block. Okay, so if I mine this also, what it does immediately, it will automatically, if the mining has been done properly, immediately it will be converted to green color and a block will be created. Okay, what I want to show you from this particular example is, if I want to change the data of the second block, you can check out here. If I want to change the data of the second block, let me add CSC 1 2 3. Immediately that block also changed, and the succeeding block also changed. Why it has to change? Because the third block previous hash value will be the second block hash value, right? So that is an important aspect you have to remember. Let me remove that. Okay, it will be correct. Okay, let me go for the first block. Let me take the value like VVC. That's all. Okay, why the second and third block also change? Because the first block hash value output will be the previous hash value for second block, and second block automatically that will be vanished because we had changed the data there. Some attacker changed the data, so the second block hash value is completely dependent upon by third block. See, this is one of the example which you can understand and how it works. Okay, so this is also one of the important thing can learn from this very simple. Those who are beginners for this blockchain technology and those who want to do a lot of things in blockchain technology, they can refer this website. That helps you a lot by understanding some basics of networks and basics of cryptography. You can able to learn this. Okay, that is what exactly better example which I can tell you about hash value and how it works with hash value. Okay, so these are 5 important characteristics of hash value. As I said, once a data is given, I can generate the hashing code. If I have the hashing code, I can able to get back your original data. Deterministic, I think again the value are totally different. Fast computation, it will take very few time to generate the hash value. And avalanche effect, if some small data changes, the complete data will be changed, and it will withstand the collision. I think I said about this also. If two or more blocks, they want to come up with the same at the same time, they want to generate the hash value for the same data, then the time slots will be considered. Okay, so this is what exactly the first important feature of your blockchain. And second one is immutable ledger. Okay, I hope so you know the vocabulary meaning of immutable. If once changed, that cannot be refined back. I mean, we cannot able to come back, taken back. Okay, so that property is very finest in case of blockchain also. Let me understand this in a greater details. The better example is land deed example. So what I depicted here also, land deed. For example, I want to give the proprietorship of that land to somebody else. Okay, what I'll do the affidavit, right, with the help of common ledgers format and all. Once that is done, you cannot able to modify it, right? So in a similar way, if some attacker, if he or she want to modify in any block in the network, they cannot able to modify back the data. Okay, that will be informed to all the blocks in the network. Okay, so I'll speak you much on this in a greater details of this. I think you can able to understand in a greater details. In a traditional ledger, they used to write the name, the person name, and all the details of the land and all. I think you can able to see here the small change I had done in the last one blockchain. For example, okay, an attacker who comes in between. Okay, so what it has to replicate, the further blocks has to replicate or state that, oh god, okay, this block has been affected, so the further things has to be get affected, then only we can assure that the blocks are working fine. Correct? No, so immediately the further blocks also get affected. Why? Because of the the previous feature what I had explained. Okay, so this is the property called as immutable property. Mutability or mutation is something that keep on changing. Immutable is once changed we cannot able to get back. Okay, once this is done, they came to understand that the block has been attacked by some attacker. Immediately the data will be removed from the block. This is one of the fantastic feature what we are called as immutable ledger or immutable property. Okay, and this also had depicted in the I think with the help of that website, where if I change some data from CSC to CSC 1 2 3, immediately the second and third block will be automatically changed, right? So that is the beauty of your immutability what we have in your blockchain. Okay, so immediately that will be identified by the rest of the blocks, and they will remove the complete data from that particular block. I hope so. You got two important features or facets of blockchain technology. The third important feature or characteristics of this blockchain is called as distributed peer-to-peer network. Okay, a distributed peer-to-peer network is a mechanism. I think you might have been heard of this name in your classes or somewhere. Peer-to-peer network is a type of network where they don't have any intermediate person to help us to communicate. Okay, in case of centralized network, if you would have taken an example of client server, which is a centralized network, whatever the communication you are going to do with the help of client, whatever with the help of servers, everything has to be replicated in your client side, right? Okay, I mean server side or client side. Okay, so the server used to monitor the server used to monitor each and everything, and it will help us to you know monitor each and everything and each and every transaction. But in case of distributed peer-to-peer network, we don't have any kind of centralized node, or it might be of your intermediate nodes. Okay, the individual nodes, if they want to communicate, immediately they'll bombard the request to all the neighboring nodes. If all the neighboring nodes they have something, they'll reply back. That is the meaning of distributed peer-to-peer network. What a major drawback of centralized network, if a single point of connection, if that fails to work, the complete network fails to work. Okay, and the load balancing, security, everything fails in case of centralized compared to distributed peer-to-peer network. The better example with few technical operation what we can use in blockchain I had depicted here. Let me consider 6 nodes, they are connected. You may have a question like, so each and every node will be having single block. They have some many blocks. Why we have many blocks in each and every node? Those blocks, an example. Okay, the first block is created at first node. Immediately that block or that transaction will be highlighted to all the nodes of the network. Okay, and if the second block is created by second node or third node, whatever, immediately that block also replicated it all the nodes of a network. This tells you the feature of transparency. The better example for this is if you would have taken a financial transaction of your well-beings or whatever, if you people want to like if you people want to transfer an amount from A to B. For example, we have 2 nodes, a person A and person B. A person A, if you want to transfer some 100 rupees to person B, that will be transacted and he will receive. But in case of this distributed peer-to-peer network or the blockchain technology, whatever the transaction that is triggered from any end, that will be highlighted at all the nodes who are connected to those nodes A and B. Okay, so not the personal credentials will be shared, but a transaction has been happened from this node to this node. That will be highlighted at each and every node of a network. Okay, that is the meaning of the transparency feature what we have here. In the same way, each and every node they possess 7 blocks in this example, because 7 blocks are created at different parts of the nodes, and each node will be aware of that blocks. Okay, a new block we will call it as a child block. If it is created at the first node, that will be forwarded to all the connected nodes to that particular block. Okay, a new block has been created with the hash value, and yes, they'll accept all the hash value, and that will be attached to particular blockchain. An example. Okay, at that interval of time, there will be an attacker, and that attacker tries to add up some other hash value with other block in between that particular blockchain. That will be immediately replicated to the further nodes, all the rest of the further nodes. Okay, immediately that block will be replicated by all the succeeding nodes, preceding nodes, and also that will be sent back a connection request connection, that attack connection to all the connected nodes of that particular block, saying that an attacker tries to insert an attacked block in the chain. So what we can see, the red color line, right? So that indicates an intimation to the first node, second node, and the fourth node, saying that, you can see the red color line, right, where the connection has been done. So saying that the attack has been attacked. Okay, so immediately that will be informed to respect to those nodes, and immediately that will be detached from the network. Okay, so these are the features what this distributed peer-to-peer network possesses. Okay, and I'll tell you a few more points regarding this in the further slides. We can have before that, let me study what exactly the meaning of mining. Until so far we studied what is hash value, what is distributed peer-to-peer network, and all. Now we'll study what exactly and what is immutable or immutable ledger. The fourth important property what this blockchain process is called as mining. How exactly it mines, who is the miner, uh, how this mining happens and all. Okay, each and every block will be having a transaction similar kind of this. You can see here, mm, where the previous hash value will be having some value like this, and hash value with some value, and data which the transaction which they want it from Krill to Heidelin and whatever. Okay, so the number of the name of the block what we created is 3. Okay, so what it does is the previous hash value it will check out, and whether this hash value is a valid hash value it will check out, and it will process to I want to I want to add this block to the network. What it does is it will check with various hash values. It will go for hash value with this hash for 20th block, 20th nonce, the hash value will be this. For 21 nonce, the hash value will be this. Similarly, okay, the mining operation takes place. The mining is nothing but how the mining will does. For example, in case of some like if you are not a robot, they'll ask you to select the images, right? Or they'll ask you to solve some equation like 5 + 7 and all. In the similar way, the job of the miner is he will try to give the complex mathematical equation, and the user, if he want to add up to the block, he has to try to solve that equation, and he has to come up with a hash value, and whatever the hash value he is going to determine, that hash value should be the minimum hash value in the block, in the pool. Okay, all possible hashes will be calculated. You can check out here from the largest to the smallest. The possible smallest hash value generated across different nonce. We have different nonces, right? When in the example also I showed 1 2 3 or 0 3 20 21 and all. Okay, for the different nonce value, we have to identify, for example, the target hash values are the red cross mark what were indicated in the pool, in the lavender color pool. Okay, out of that, the smallest hash value is the below one. Okay, so you can refer the values for the upper hash value. The biggest hash value what were indicated 64 characters, alphanumeric hash value. For the middle one, again we have starting with some 8 zeros, and the last smallest hash value with starting with 16 zeros followed by 16 alphanumeric characters. So it will determine which hash value will be perfectly matched with that. Okay, so the target they had mentioned is this hash value. Okay, the value which are generated below this hash value, any value below this, it will be considered as the mined value, and that block will be added to the network. Okay, remember, not the largest one, always it will choose the smallest one. Okay, and that setup is called as choosing the target value. It will generate for 143, then the hash value will be something like this. For a hash value of for 5012, it will come up with the hash value like this, and that hash value will be a possible hash value that can be mapped with this target value, and that block will be selected, and that will be attached to the network. Okay, that is the meaning of mining. Okay, and you may have a question: a real-time application, who is going to mine? The user, if you want to add up in between them, they'll pose the question or they pose the mathematical equation, and the user, they want to insert between the blocks, they have to solve that and they have to come up with all the values, and whichever the value they process, and many people will be mining in the meanwhile, not only one user, and the value that satisfies the target value, that block will be added to that particular network. Okay, so this is the meaning of mining. For more details of mining, and just I'm giving the pinch of a salt of complete blockchain in this complete lecture, and for further details, if you have any doubts regarding mining or blockchain or whatever, I can put up your question, or you can also join our community. We have a community called as Web 3.0 community, where we are working on different algorithms and different platforms on blockchain. We can also help you to work on those platforms. These are different features. What blockchain poses. One is hashing algorithm, and second one is immutability. Third one is deterministic. Third one is immutable ledger, followed by peer-to-peer network, followed by mining. How mining works. Okay, these are different features. What this particular blockchain process. And one more important feature is called consensus protocol. I'll explain that later. Before that, let me put up in front of you very famous important mechanism called as Byzantine fault tolerance mechanism, which is one of the fantastic mechanism that will be. It's not a new mechanism which was generated for blockchain. It's a very oldest mechanism which was already there, that we are using for this particular blockchain, where I'll explain the scenario where we have 4 nodes. The first node, they wanted to attack on the emperor, which is in the middle. They'll select the leader among themselves, and they had selected the first node as a leader in this example. What the rule is, the leader will send a information that we will attack. There's a question whether to attack the fort or whether not to attack. Okay, that all mainly depends upon the leader, the message what he conveys. Okay, what the leader conveys a message, yes, we will attack. If it is conveyed to the all the nodes, okay, indirectly the second node again send back the message to first node, second node, third node, and fourth node, and the third node again send back the message to the first node, second node, and the last node, and the last node again send back the message that we will attack. Yes, we will attack to second node, first node, and third node. Okay, I mean to say that they will consider the maximum yes or maximum request, maximum prioritized number, saying that whether to attack or not to attack. That's all. A very simple mechanism called as Byzantine fault tolerance mechanism. Okay, in this case they'll attack. Okay, we will see why we require this, because the miner they have to decide whether to consider that block to my network or not, right? Okay, so that in that cases, this Byzantine fault tolerance BFT protocol or mechanism plays a very vital role. There's a situation where an attacker lies in the network. The leader will send a message that we will attack to the second node, third node, and the fourth node. But the second node, he will never send back a message not to attack the first node. Why? Because he is the leader node. What the second node will does, he will send a message to the third node and fourth node saying that not to attack. But the last node, fourth node, he already got a message that we will attack from the second node, first node and third node. And third node also got a message from first node and fourth node saying that we will attack. Green color says we will attack, and red color says will not attack. Okay. Based on the number, now you can consider the third node. Okay, how many yes he got? One from the leader, one no from the attacker, and one from yes from the fourth node. So he got 2 yes and 1 no. So he will choose yes. In the similar way, the fourth node, he got 1 no and 2 yes. So he'll also select go for yes, and they'll attack the empire. I mean to say that take the and they'll take the highest number. Okay, and many of the situations where the leader itself is an attacker. What happens when the leader itself is an attacker? Where he will send two yes requests to two nodes and one node to the last node. Okay, a situation, a scenario where, but the last node receives yes from the other two nodes. It will be a broadcaster. It's a flooded data, kind of flood data. Okay, so again, the majority will be considered, and they'll come up with the conclusion that whenever they'll get the maximum number of verses, they'll go for it. You can check out in this scenario. The first node will be a leader node, and all the nodes are the regular nodes. And the first node itself send a false message saying that not to attack to the fourth node. Okay, but he will send yes to attack to the second node and the third node. What the second node will does, again he'll send a yes message to second node and fourth node. And what the second node does, he will send a yes message to third node and fourth node. What about the fourth node will does, he will send a not to attack to second node and third node, but each and every node will have a maximum value of 2 yes and 1 no. So will they'll attack and they'll agree for the attack and they'll attack. They'll not obey with the attack request. Okay. What I want to tell you is Byzantine fault tolerance mechanism will choose up the maximum value, maximum majority in the network, and they'll can decide whether to add to the network or to the leave. We should not. We have to detach the node from the network. Okay, that will be decided by Byzantine fault tolerance mechanism. This is one of the fantastic algorithm or mechanism that will be used. And at last, we'll see very famous protocol. I was keep on mentioning consensus protocol. It's one of the finest algorithm, which protocol which is followed by blockchain technology. Consensus is nothing but compromisation. Like we compromise for one thing, right? That's called as the vocabulary sense of consensus is compromising. This protocol is not a new protocol or new algorithm. It's a very old classical algorithm. But for this blockchain technology, they are adopting that mechanism. Okay, how this works? Basically the vocabulary sense of consensus is we will agree for one decision. Okay, there will see a few challenges how we have in the network, how consensus protocol can able to check out with those things. Okay, the first node, the last block is an attacker. This is called as challenge one. Okay, what the and will have the competing chains. This is called as challenges. Okay, the first attack is called as challenges, and that will be highlighted to all the nodes in the network. Immediately they'll go with the prior majority, and based on that they'll delete the node from the network. This is what the consensus compromisation does, that to detach that node from the network. Okay, the second one is, the second mechanism is where we have two nodes. They'll follow, I mean to say, the first node and the last node. Both the nodes, they will be having a new block that will be attached to the particular node, okay, the particular network. Okay, in those situations, whether to add both the nodes or whether to delete both the nodes. Such nodes are called as competing nodes, right? Because equal majority, if they have equal majority, like 3 is to 3 or 4 is to 4, okay? Whether to take up such nodes or whether to delete such nodes, that will be considered by again with 10 second. Okay. Okay. In the second challenge, what we have is uh, we have two nodes. If they want to add up two blocks at the same time, what it happens? Okay, so whenever they have two nodes, they want to add up the network at the same time. They will check out different scenarios like how many nodes they'll get. I mean to say the highest. You know. Check. The two nodes, if they want to take up such nodes are called as competing nodes. The second challenge of your consensus protocol. The first challenge is whenever they have an attacker in the node, that will be broadcasted to all the nodes in the network, saying that the attacker comes in the block, and obviously they will be come to a conclusion that based on the majority saying that yes, we have to remove this block from the network. The second challenge is competing sign, where exactly the two nodes at the same time, if they want to join. For example, the first color is orange color and the second color is the lavender color. Hold on. Not sharing screen or share screen. ಪ್ರೆಸೆಂಟೇಷನ್ ಬಂದಿಲ್ಲ, ಪ್ರೆಸೆಂಟೇಷನ್ ಓಪನ್ ಮಾಡಿಲ್ಲ ಅವರು. ಈಗ ಕಂಟಿನ್ಯೂ. Okay, the second challenge is we have two blocks, two nodes with two different blocks at the same time. The first block, that is, we consider as orange color, and the last color, what we consider as a lavender color. And they will send the updated connection to all their neighboring nodes, saying that we have a new block. Based on the majority, they'll take or they'll leave. Okay, such operation is called as competing nodes. And consensus protocol mainly works with two important factors. One is proof of work, and one is proof of stake. Proof of work is a mechanism where the user, if anybody wants to join the block, they have to satisfy some mining operation. Such operation is called as proof of work. And proof of stake is nothing but the mechanism what they had included in proof of work, that is called as proof of stake. In the layman example, if you want to tell you this, the proof of work is nothing but to mine that target value. Proof of stake is nothing but whatever the operational mechanism used in proof of work is called as proof of stake. These two typically used in consensus protocol, very importantly. And in the previous case also, whatever the example we have taken, what the last node will does, he's going to have connection with the other node. He will share that particular block to the neighboring block, and in the same way the first node also shares the block to their neighboring nodes. And at last they will come to a conclusion that they have a majority of this orange color compared to the purple color, and they'll add up the orange color block and they'll leave the purple color block, and hence that block is called as orphan block. Okay, the block which are detached from the blockchain, we can call them as orphan block. And the block which is added to the node, we can call it as the new child block. Okay, so these are the major important aspects which I want to discuss in this operation, in this blockchain technology. If you have any questions, you can put up your question. And I also have different applications to come up with this blockchain. I'll quickly, in a couple of minutes, I'll go with those applications. One is e-voting application. Actually, I used to deliver the complete this for 1 day or 3 4 hours and all. I'll try to give some brief overview on this also. E-voting is nothing but we are following the classical ballot operation where there's centralized mechanism and all. We used to hear here and there, present media, that many attacks and all happen in case of voting operation also. So we can able to switch on from the classical mechanism to this blockchain mechanism also. This also we built on this, where the individual user, if they want to vote, they have to generate a hashing value using the block they had generated. And once the if the user want to cast the vote, they have to go for this portal and they have to give that hashing value. The transaction will trigger, and some ether value. This all built on a tool called as Ethereum. Ethereum is one of the blockchain tool. Can also use this for if you want to do some work on projects or any research on this, you can use that. It will use Solidity as a language, where the transaction will be triggered and immediately the vote will be casted, and some ether value will be deleted. Ether is a Bitcoin in Ethereum, okay, or some false currency in Ethereum. Okay, India will not support Bitcoins. I think we all know it. Few people know about this. Why? Because Indian government will follow different democratic rules. But in case of Western countries, they have some collection of some bitcoins they can convert to the actual currency after some collection of some bitcoins. Okay, but India will not support that. Okay, this is one example. You have to identify wherever the requirement of decentralized network is there. We can able to incorporate that also. uh, crowdfunding plays a very vital role nowadays. Okay, funding in case of natural calamities, or it might be of any kind of require medical help or whatever. Okay, we used to announce the crowdfunding. We used to post such things, and we don't know whether the fund what we had donated, whether it is utilized properly or not. Correct. So in such situations also we can able to use this blockchain technology, where each and every transaction will be noted, and we can able to have a satisfaction that our money is properly used. This is also one more application what we built. We had opened the campaign initially using some Ethereum, again same tool. At the back end, front end, my students that had used was some JavaScript and all. This is also one more important application. You can also think of it wherever the decentralized application is required. You can remove the centralized application, and also we can use it in medical application. Lot of applications are there. Okay, and if you want to upload any files, we have to go with interplanetary file system. It is again one of the important blockchain technology. You can also, if anybody wants more details on this, please kindly contact me. I can able to help you at any point of time about regarding this. We had built a small portal where if you want to upload any files, you can upload whatever the files it might be. If the files are not valid, the other files are not, I mean, good. Same kind of BitTorrent. If the movies are not so clear, they will go with the other copies. No, in the same way. These are the different application, and no centralized people will be there. Nobody can able to delete, or nobody can modify your data and all. That's what, if it is modified, everyone will be notified. That's the beauty of this. These are different things which I want to help. If you really want to join us, we can have a Web 3.0 community is there. You can able to join us. And thank you. If you have any questions, I can take up your questions from your end. If you have any questions, you can ask me your questions. I am really happy to answer all your questions. Now, this is for the rough overview of the complete aspects of blockchain technology. And it's not about 1 hour talk or giving a flavor of blockchain in 1 hour. It's not so easy. I just tried my best to give some insight towards this. If you have any questions at any point of time, you can contact me. Anyhow, you all people know my mail ID, I guess. I can visit our college website if you require. If you have questions right now, I'm very happy to answer your questions. Okay, if no questions, I'll wind up. Thank you so much. Thanks for listening.